All right, let's just dive right into this. Welcome to this explainer, where we are going to get our hands dirty and build a truly self-healing, production-grade cloud architecture. Honestly, if you've ever laid awake at night worrying about your servers crashing, you are absolutely in the right place.
Picture this for a second. What actually happens to your website when a server suddenly dies out of nowhere? Or what if your traffic spikes 1,000% in a matter of seconds? Does your application just crash and burn, leaving all your users staring at a frustrated page not found error? Well, today we're building a system that not only survives those exact scenarios, but one that we will intentionally try to destroy, just to prove to you how unbreakable it really is.
So in the cloud computing world, you basically have two main ways to handle more traffic. Vertical scaling is a lot like taking your everyday car and constantly trying to cram a bigger and bigger engine into it so it goes faster. Eventually, you're going to hit a physical limit, right? And if that one massive engine fails, you are completely stranded. Horizontal scaling, on the other hand, is like adding a fleet of smaller, highly reliable, and much more cost-effective cars to carry your passengers. If one car breaks down, the others just seamlessly take over. And in the cloud, horizontal scaling is hands down the superior, crash-resistant choice.
Here's our quick roadmap for today's explainer. First, scaling and healing, then preparing the setup. After that, we'll build the auto-scaling and handle load balancing, and finally, we'll run some testing failures and stress. We're going to build this entire AWS architecture logically, step by step.
Okay, step 1, scaling and healing explained. Let's get the core concepts down first.
To put it in really simple words, auto-scaling and healing is basically the automatic process of adding more servers based on the stress or load your app is experiencing, and then seamlessly replacing servers if they happen to crash. And the best part? It happens completely without human intervention. This is the real magic of the cloud. I mean, in a physical data center, you can't just magically spawn a new piece of hardware when your traffic spikes. But here, the system manages that stress and heals itself entirely on its own.
Moving right along to step 2, preparing the setup. Let's look at what we need before we start building.
First up, we need SNS, which stands for Simple Notification Service. You can basically think of this as a highly efficient publish and subscribe group chat for your infrastructure. We configure an SNS topic so that whenever our cluster automatically heals a broken server or scales up to meet some new demand, it instantly sends an email or SMS alert right to us. This way, as administrators, we're never left in the dark about what our system is doing behind the scenes.
Our second prerequisite involves a pretty clever little trick with a user data script. Think about it. When we launch all our identical web servers, if they all just display some generic welcome page, we'd never actually know which invisible background server is handling our request, or if our auto-scaling is genuinely working. So we write a quick Linux script to inject the server's unique IP address and hostname directly into its HTML. When we load the page, it literally tells us, this web page is coming from node and IP, so we can physically see and track our fleet.
All right, on to step 3, building the auto-scaling. This is the core construction phase.
To make an auto-scaling group work perfectly, we really have to hit 3 fundamental milestones. First, we create a launch template. Second, we configure the actual auto-scaling group. And third, we define the scaling policy, which dictates exactly when to add or remove servers.
The heavy lifter here is the launch template. Think of this exactly like a cookie cutter. AWS needs to know precisely what kind of machine to build when we aren't looking. So we fill out a template with the exact instance details, the operating system, the machine type, the security firewalls, and of course, that clever user data script we just talked about. Whenever a server dies, the auto-scaling group just grabs this cookie cutter and stamps out a brand new, identical replacement in seconds.
Next, we have to set up the auto-scaling group capacity parameters, and this is incredibly important. You have desired, minimum, and maximum capacity. The desired capacity is your starting cluster size, let's say 2 servers. The maximum is your ceiling for heavy traffic, maybe 4 servers. But look really closely at the minimum. We never ever want our minimum to be 1. Why? Because if that single server crashes, it takes anywhere from 30 seconds to a couple of minutes to spin up a new one. During that time, your users are getting request timeouts. By setting the minimum to 2, if one fails, the backup just seamlessly handles the load while the new one is being built.
That brings us to step 4, load balancing and integration.
Enter the classic load balancer. This gives your users a single static URL to hit, so they're always going to the exact same web address, and it takes care of evenly distributing the incoming traffic across your whole fleet. But here is the massive trick that trips up so many people. Never register your instances into the load balancer manually. If you do that, it just becomes a static list. Instead, you absolutely must let the autoscaling group dynamically add and remove them as it does its job.
And this is exactly where integration comes in. Building an auto-scaling group in one silo and a load balancer in another silo just isn't going to cut it. If they don't talk to each other, your load balancer will just show a blank page because it has no idea where the servers are. You have to go into the auto-scaling group settings and explicitly integrate the load balancer. Once they're connected, they communicate flawlessly, and new servers are registered the exact second they finish booting up.
Finally, step 5, testing failures and stress. This is the really fun part, guys. We are going to intentionally try to break our unbreakable system.
We're going to put our new cluster through 3 rigorous tests to prove it's a true production-grade environment. Test 1, we will brutally terminate an instance. Test 2, we'll crash the internal web application service. And test 3, we are going to unleash a massive CPU stress test.
So, test 1. We just march right into the AWS console and manually terminate one of our 2 running servers. Boom, it's gone. But what's the impact on our users? 0. Because our minimum capacity is 2, the load balancer immediately routes all the traffic to the surviving server. There are literally 0 seconds of downtime, no page not found errors, and in the background, our SNS topic pings us an email alert while the auto-scaling group happily stamps out a fresh server to take the dead one's place.
But then we get to test 2, and we have a bit of a mini mystery on our hands. We log into a server, but instead of killing the hardware, we just stop the Apache HTTP service. So the server is physically powered on, but the web app is totally dead. We wait, and we wait, but the auto-scaling group does absolutely nothing. So why didn't the system heal?
Well, out of the box, the auto-scaling group only checks that the EC2 hardware is powered on. It has no clue the web service inside is broken. The fix for this is a simple yet absolutely critical checkbox. We go back into our auto-scaling group and enable ELB, or Elastic Load Balancing, health checks. Now the system is finally smart enough to monitor the actual service level and application health. If the web page stops responding, the load balancer flags it, and the auto-scaling group immediately replaces that bad server.
All right, the final boss, test 3, the stress test. We log into our servers and run a brutal Linux command called dd, which routes a continuous loop of zeros into a virtual black hole on the system. This simulates a massive, instantaneous traffic spike. It's an endless, heavy task. Instantly, the CPU spikes to 100% on all our nodes. Our scaling policy kicks in because it sees the total cluster load has crossed our threshold. After a short 5-minute warm-up evaluation period, the auto-scaling group successfully triggers the launch of a 3rd instance to handle the massive surge in traffic. Flawless execution.
Now I need you to hear this one absolutely crucial takeaway from this explainer. Do not forget your scale-in policy. When we stop that stress test and the CPU drops back to idle, a smart system needs to shrink itself back down to its minimum capacity. If you only configure scaling out, your fleet will grow and stay huge, and you'll be left holding the bag on an enormous bill for idle servers. Scaling in is just as important as scaling out.
So there you have it. We've successfully built a cluster that shrugs off hardware failure, recovers from application crashes, and scales beautifully under extreme stress. Now I want to leave you with this. How will you use horizontal scaling and self-healing architecture to make your next cloud project truly unbreakable? Think about applying these simple but incredibly powerful AWS concepts to whatever you are building right now. Thank you so much for joining me for this explainer. I really hope you found it helpful, and I'll catch you on the next one.